Okay, we're going to walk through the setup of setting up the Masso G3 with the RapidChange ATC magazine. And the first thing we're going to do is wire up the tool recognition sensor. The tool recognition sensor requires a 5-volt power supply. In our premium models, we supply a 5 and 24-volt power supply combo. The wires coming from the cable are color coordinated with the wires you see on the screen here. The red being the 5-volt connection. The black wire will go to ground. That ground wire also has to connect to the Masso to create a common ground between the two. The green wire is our signal wire for the sensor. Now this is going to need a pull-up resistor. On Masso's website, they recommend a 5K 7 resistor, and I didn't have any, so I used a 5K 1 resistor, and it works just fine. So that resistor is going to be placed connecting the signal wire to the 5-volt power supply. And that's really it. It's quite simple. So we're going to go into Masso in the F1 setup screen, and we've got our signal wire connected to input 5, and we're going to name this auxiliary 5. You can double click on it and you can really name it whichever auxiliary pin. Let's see, get to the inputs. Okay, auxiliary 1, 2, 3, 4. You'll see 5's missing because I used that, so we're just going to cancel out of here because I've already got it set up. So auxiliary 5. Now we want to make sure that when the beam is not broken, we have a low signal. As you can see, when I block the beam, the signal goes high, and that's what we want. If when you pull this up, and if it's wired the way I wired mine, this is going to come up as a no. The default is no to invert the signal. So pressing spacebar will invert the signal, and we want the signal to be low when it's not triggered. The next thing we need to do is set up Auto Tool 0. So we double click on that. We're going to enable Auto Tool 0. We're going to leave this unchecked. Tool Setter X position and Y position will enable both of those, and that will be the position centered with the tool centered on the tool setter. Z safe distance to tool setter is going to be the height at which we want the probing of the tool to begin. So it's best to put the longest tool stick out that you're going to use to find that position where you want the spindle to start moving down to probe the tool. And then we have our tool 0 feed rate. I've got mine set at 100. Could be a little less than that. It seems to work good for me. So we're going to save this. Next we're going to go to the tool changer menu, and we're going to pick linear tool changer type 2. Now we want to leave tool holder 0. We want to leave all these zeros 0. We can put in a tool change feed rate. I chose 500. We're going to choose our number of slots, and then in each slot position we're going to record the position of the tool setter. That's very important. This is all going to be the same. All these values are going to be the same. It's going to be the tool setter position. So we'll save that. Save that. And then we need to go to tools and offsets. Tools and offsets. I've already started this. You double click on tool 1, and we want to come down and associate that with slot 1. Save. Slot 2. Slot 3. slot 5. Now, you'll notice that in slot 1, we've got a number here in the Z offset. You're not going to be able to set that number. That is going to get recorded when the tool gets probed. The tool diameter and tool wear. So save all those. You'll see these positions. The only reason tool 5 doesn't have a number here in the offset is because I haven't picked it yet. Setting up the tool changer like this will allow automatic tool changes without the need to press cycle start. So for Masso, the way we actually handle the tool change is through subroutines. Files 1 through 5 are going to be tool loads for the corresponding pockets, and 11, 22, 33, 44, and 55 are going to be the corresponding unloading files that will get called from the M98, which I'll show you a file right here, test file that I ran some G-code, and you're going to see before load tool 1. Now this is coming from the Fusion 360 post processor, but this is what we want to see in our G-code file. We're looking to pick up tool 1 here. So up here we have M98P1, which corresponds to the file 1.nc. Now all of these files need to get placed into the same folder that you're running the G-code from. This is this G-code file. These files are all in the same folder. So P1, M98P1 calls this file here. And this is going to be the sequence of events for loading tool 1. What you're going to have to put in is your pocket 1 positions, X and Y pocket 1 positions, your spindle start position, which is typically 30 millimeters above Z engage, which goes here. Z disengage is generally 10 millimeters above that. And then we do the double tap where it finishes torquing the clamping nut. And then it's going to call an M98 within this file, which is P20, which is this file here. So when this file gets called, the spindle is going to move to zone 1, where it's going to check that the beam is blocked, meaning that the clamping nut is on the spindle. If it fails, it will throw a message saying zone 1 load failure. It'll move to Z0. It'll pause for user input and load the tool on and continue. At zone 2, if the beam is clear, that means that the clamping nut has fully threaded onto the spindle. And if that hasn't happened again, it will display this message and pause for user input to let you finish putting the tool on, and then it will hand back to this file, which will move over the tool setter at this point. Well, it'll move to Z safe clearance, and then it'll move over to the tool setter so that it's in position for Masso to handle the M6. So if we go back to the file that's running, we're going to see that Masso picks up the tool, starts the spindle, and this is where the tool offset gets put in. So then if we go back to our file, the tool has been loaded, it rises to safe clearance, make sure that the spindle is off, and then we are in position, and it will call the M6 tool 1 and set the tool length offset. So then, once it runs the tool path for tool 1, then it's going to call M98P11, which is going to drop or unload tool 1. And it's basically the same thing. You need to enter your pocket 1 X and Y positions, your spindle start position, the Z engage position, and the Z disengage position. Then it's going to call, after it goes through the sequence of events to drop off the tool, then it's going to call M98P21, which is this file here, 21.nc. So this is basically the opposite of loading the tool, and we just need to put in zone 1 position and zone 2 position. And it functions basically the same way as the other one on failures. Then we hand it back to the file, continues to run the G code, which next will be to then call the M98 for picking up tool 4. So this file was created in Fusion 360, and Guillaume Ferland's written a post processor that we have available that will put all these M98s in the proper place for pretty much seamless post processing and generate the G code to work with RapidChange. If you're using Vectric, we have a Vectric post processor. However, the Vectric post processor is not going to put these M98s lines into your file. It's possible we could get it to do that. I don't know. It's not very sophisticated. Fusion 360 is pretty sophisticated in what the post processors will do. I haven't looked into that much, but this is basically what you want to see in your files. At the before calling for a tool, we need the corresponding subroutine to call that tool, and when the tool path is done, we need the corresponding subroutine to drop the tool, and then the corresponding subroutine to pick up the next tool, and so on. So that's about it. It's pretty simple. With Aspire or Vectric vCarve, there's a little bit of mechanics involved, but this will get you up and running tool changes on the Masso G3 without having to use cycle start after every tool change. Thanks for watching, and happy tool changes.